All right, we are very, very excited to start the panels, the talking sessions over here at Hall 1. We have a very, very exciting talk discussing how AI can be the driving force in climate action. I am very, very excited for this talk. Please welcome our lovely panelists, Himanshu Gupta, Pullen, Pablo, and our moderator, Hynes. All right, that's it.
Well, thank you for coming to the most important panel at the AI conference, which was mentioned earlier, right? No, this really is, I think, one of the serious issues that we have to think about, and we have a great group here to discuss that. We also have a special guest, ClimateAi is going to join for a quick session in the beginning. Please don't take video. You can take pictures, but please don't post any live video. You're allowed to post pictures. So I do think that the climate problem really needs this level of attention. I've been very lucky to be working in climate innovation for 22 years now, and I can say that we are not moving fast enough to solve the problem. And one of the only things I think that can help us move more quickly and quick enough is AI. So I think we want to hear a little bit from Reed, and then we'll jump into the panel.
Hello, ClimateAi. Thanks for joining today. We're really glad to have you as part of this campaign.
Hello, Todd. It's great to be here with you, and thanks for having me.
We are in a climate crisis. The world is not moving fast enough. How can AI help us develop new technologies and deploy those technologies and solutions to help address this challenge?
Yes, 100%. I agree we're in a crisis, and that's why AI is a key tool in the toolkit. One of the things I can see is that AI can help accelerate the discovery of solutions, from more efficient solar panels to optimizing energy grids. We can use machine learning models to predict extreme weather events, optimize supply chains for green energy, or even improve carbon capture technology. But the real kicker is AI's ability to scale. Once we identify the right solutions, we can deploy them globally at a speed humans alone just can't match. So we're talking about AI as a force multiplier here, one that can both drive innovation and scale solutions faster than ever before.
Great answer. As far as the next question goes, a lot of people are concerned about the amount of energy associated with AI. How do you think we can address those concerns?
That's totally valid. And, I think it's a big challenge, but when we can meet it. First, we need to make data centers more efficient. AI can optimize server loads and cooling, cutting energy use. But beyond efficiency, we have to push for renewable energy powering these centers. There are already examples of this happening, like Google and Microsoft committing to carbon neutral data centers. It's a mix of innovation and policy, optimizing today's system while moving forward toward clean energy to power AI.
All right, great answer. Now let's go back in time and ask ClimateAi from 2004 what he thinks about climate change. Hey, ClimateAi from 2004, put down that palm title. That's some serious questions for you. What do you think about climate change? Are people even talking about it? And what do you think is going to happen in the next 20 years?
Well, Todd, climate change is definitely becoming a bigger concern, but the conversation is still a bit more technical and urgent. We're hearing a lot about global warming and greenhouse gases. The Kyoto Protocol in '97 was a big step. Countries agreed to cut emissions, but the US didn't sign, so there's been some debate. Even companies like BP are talking about going beyond petroleum, which is a big shift. There are hopeful signs like the Montreal Protocol helping the ozone layer recover, but then events like Hurricane Isabel last year were devastating and got people talking about extreme weather. I've heard a bit about renewables like solar and wind in places like Germany. However, there's a lot of worry around climate change and how it will affect things like agriculture and water supply. So it's clear we need more innovation to tackle these challenges, but there's still a debate about balancing environmental action with economic growth. So in 20 years, it's tough to predict, but I think climate change will definitely drive innovation across industries. Well, now you've heard enough from me, and I'm excited to hear from the rest of the panel. So thank you for having me.
Thanks for all the insights, ClimateAi. Hopefully we live up to your expectations of innovation over the last 20 years. And let's move on to the panel to see what they have to say.
All right, thank you. Thank you, Rita. Pablo, because we're a little bit late, has to maybe leave early. So I want to make sure we prioritize his answers. no offense, but he may have to leave. So based on the feedback that Reed had, how would you answer those questions around AI and its ability to help us move more quickly to solve the climate crisis or innovation in the clean energy or clean transportation space?
Right. So moving to all, I come from the manufacturing world with MA cars, everything design. So I think we're all in agreement that climate change it's even worse than has been predicted. And I think we all have our responsibilities to bring the CO2 and make a better world. And then you look at the automotive industry, not only works to mean the manufacturing of the vehicle, but works in the supply chain, the dealers, the entire chain was in growth. And I could have it from the crate to the grave. So from the beginning of fuel to the actual vehicle. I think AI will accelerate the innovation, whether it's in battery development, whether it's in the customer interface, whether it's making things more efficient. So all the timing that we're developing the cars can take 4 to 5 years. If you can kind of bike fast and make it more efficient throughout the supply chain, the entire CO2 reduction will be collapsed. We have targets as a company that by 2010, we might be carbon neutral. But as I mentioned before, since the acceleration of the iteration is faster, it always need to develop. My final point here, and I go more from a consumer point of view, everybody agrees that the climate is critical. But we need to make the products and services affordable so the regular consumer can buy an environmentally friendly product. So I think AI can have a critical factor in this.
Right, thanks. Himanshu or Julian, have ideas on how AI can accelerate action to solve the climate crisis?
Yeah. So, good morning, everyone. First of all, I'm very excited to see many avatar or Pete Hoffman actually being very real. The lip sync is pretty good with the dialogues. So even that excites me from the perspective of we trust Reid Hoffman as a technology leader, right? Having started LinkedIn. Now imagine there are millions and billions of farmers out there who trust their local agronomist to give them advice. Now imagine now if we can use the same technology to create a local agronomist, a video avatar of a local agronomist who can give a very customized advice to farmers on when should they plant, when should they harvest, what seeds should they use because the farmer trusts their local agronomist. Right? So I think in this case, what we are not talking about is now this is solving the problem of trust, because we trust people. So so that's one thing that I'm excited about. The other is the way we think about AI in climate is an accelerator to solutions of climate change. If you look at the light bulbs on topical heads right now, this is like a 100-year-old, a century-old invention. Edison, along with his co-inventors, came up with this invention, and it took them almost 3 to 5 years to perfect the filament for this bulb, light bulb. And that's why it took them 3 to 5 years, because they went through like 1,000 to 500 attempts of trying multiple materials that can withstand high temperatures for almost like a year, right? Now imagine if they were to have the same simulation technologies in machine learning that we have access to, light bulb would have been invented like minutes. Analogy of that is what we do in seed industry. We know farmers are desperate to get access to climate resilient seeds, right? And the climate is changing, and of course we are going to see a drop in the yields of crops by 30%. We're already seeing them right now. If you look at eating chocolates to wheat to popcorns and whatnot. So the way we do that is like, hey, how do we help seed companies identify the right trait to launch climate resilient seeds 30% faster and 20% cheaper into the market? Like the way you're simulating the filament of a bulb that can withstand high temperatures, you can also simulate the right traits of a seed at a particular location that can withstand high temperatures and precipitation and or drought conditions. Julie.
Yeah, I think that the promise of that discovery piece and already what it's yielding is really quite important. Another place where we're seeing more maturation in these technologies, and I say this as an oceanographer and a meteorologist who was with a climate risk startup before going into the investing space with a particular focus on how AI shows up across climate risk and opportunities. As an oceanographer and meteorologist, what I've been seeing is a proliferation of companies who are able to make advances on short-term and long-term weather prediction because the barriers to entry are just so much lower. So with a small team of people in a short period of time, several weeks, being able to extend the predictive edge for weather forecasting against the standard models like the US and the ECMWF, European Center for Medium Range Weather Forecasting, is an astonishingly and super rapid evolution in these technologies. And one of the areas I'm focused on, I'll just wrap up here, is how do we extend those capabilities to go into the much longer range climate time horizons to help us understand the really deep, to Pablo's point, non-linear changes that are happening in our system. As a climate scientist, I think a lot about this, and we could come back to this later, Todd. But really how we can use a much more diverse set of data coming from the oceans, our oceans are the seat of our climate stability, as well as going back into the deep past of our planet when some of these dynamical regimes were visited by our Earth system. And it's super wacky data from paleoclimatology, but how do we integrate unstructured data like that into understanding this in terms of humanity's experience, uncharted terrain that we are rapidly taking the Earth system into?
So we do have the ability of seeing your questions. If you want to go to Hall 1 and ask additional questions, you can incorporate the audience, but we can come back to more impacts of AI in terms of climate modeling and accessibility was one of the things we talked about earlier. But one question is around a practical application. So can you give a very specific example of AI being used within a big company to help make work faster or increase the product development timeframe maybe that you mentioned earlier?
Yeah, so I'll give you two quick examples, real life. One is on autonomous driving. We are developing with a partner the technology for autonomous driving in Austin, Texas. The car has been driving there for 2 years, and we just incorporated AI last year. It's going to accelerate the development of the vehicle, and that will have a positive impact. Less cars because you can do share rides, so CO2 will be lower. The second one is more on the consumer base. We're collaborating with Google Cloud to use AI generative technology to, in our VW app, when you have a vehicle, you can have questions and answers on the manual, or you can take pictures and the machine will answer whatever your question is. Mm-hmm. So as this goes through, hopefully we'll reduce the amount of material that we have going forward in all these vehicles.
Okay. All right. So I've been teaching the MIT Climate and Energy Ventures course since 2008, and we've got an unbelievable group of alums that come through the class. But one of the challenges that I've seen over the years, and it's still a challenge, is getting either entrepreneurs or capital or policy to focus in on the problems that really have the biggest impact. Right? Some people go with what they know, or I'm familiar with EVs, I'm going to do charging optimization software or something. But, there's other opportunities that are much, much bigger in terms of the impact that they can have on humanity and on the climate. And have you seen ways of using AI to help entrepreneurs or investors see the bigger picture and maybe identify opportunities that are more impactful?
Yeah, I'll give an example because I, as an Earth system scientist, I think about the intertwined nature of climate and biodiversity. And so one of the companies I work with is called New Atlantis, and they're an ocean-based company using environmental DNA to catalog the diversity in our oceans. So I mentioned the oceans are the seat of our climate stability. The oceans are also the generative and life-sustaining capacity for our planet. And we suspect and we know there are billions more species in the oceans that we don't understand or fully appreciate how they're functioning in the Earth system. And moreover, these can be used to understand how to improve our products. So this company, New Atlantis, is cataloging from an eDNA perspective, working with governments and countries to have sovereignty over the data, but then use that as a database that can be utilized to understand how to improve products and, crucially, how to protect the biodiversity on our planet. There's an example of this in the terrestrial sphere. Basecamp Research raised $60 million, they announced this month, for ChatGPT for biology. So how do we actually value the biological entities and systems that really underpin life on our planet?
Yeah, I agree with Julie. And also what I liked about Pablo's point was it's very problem-focused solutions they are driving through AI. And I can totally relate to the problems that you're trying to solve, like if you're driving a car and then click a picture and whatnot. And opposed to like tech-first approach and then trying to figure out which problem can it solve. So kudos for that, Pablo. And so back to your question, I'll be very quick. I talked about the seed industry example. So our solution has been now used by more than 25% of the seed industry, both in developing countries and developed countries, on helping them launch climate resilient seeds cheaper and faster to the market. I can also give you another example, which we are not doing. It's small in India, where again, going by the problem first approach, there are more than 30 states, each having their own agriculture policy and incentives for farmers. And these are 70-page documents or 80-page documents, which in different languages, which even I cannot read. I don't have patience to read. And a farmer who is on the field for like 12 hours a day, 7 days a week, what time would he or she would have to read those? So this startup is doing amazing thing on creating like a chatbot, which farmers can actually speak to in their own language about like, hey, I am looking to buy these seeds for organic farming in this region. Tell me what all incentives are available in their language. India has around 28 different languages, right, which are spoken there. And then the chatbot will speak in the farmer's language, give them the link to like, these are the subsidies available, and you apply just one click. And it also gives updates to the farmers on like your application is at this stage, this stage, this stage. And I trust you know, it's just like, to me, the best solutions of AI in the humanitarian or social good are the ones which are already, identifying a problem where people are trying to do something which has not been done before.
So I think in all these cases, we're using AI and we're training AI models and they're asking questions. We can't get away from this question. It's pretty much everyone wants to know about the energy impact, the emissions impact of training and running these models. So I'd love to hear people's thoughts on that problem and how it compares to the opportunities that we're talking about, right? And then also, how do we solve that problem? There's a lot of different ways that we can solve that problem. And what do we think's coming? And I know you have to maybe leave soon, so yeah. Pablo, go first.
So I'm not the expert on knowing how much energy AI generates, but as I mentioned before, I look at the entire chain, right?
Yeah.
So let me give you another example. How can we reduce the CO2 using AI, even though it generates more energy? So if you look at the product development, that it takes 4 or 5 years. In the past, and I'll tell you in the past 5-6 years ago, we would do 5 to 8 clay models once we had a developed car. Well, you don't need that anymore. As you go through all these iterations with AI, you shorten the cycle. Instead of having 8 vehicles on clay, you can have 1. And think about all the energy, the supply chain, the logistics, the movement of material that you save through the entire chain. Now, obviously it's going to be an offset, but I think the gains, since the supply chain of our industry is so big, it's going to be far more beneficial than any incremental AI electricity that it will be used.
Got it. Understood. Any thoughts?
As a former engineer myself, I'm less worried about this problem, to be honest. Although in the model, I used to be the lead emissions modeler for India. So when I do the modeling, I can totally see the energy from data centers to be around 8 to 9% of world's energy consumption by 2030. But that's based on the current technology regime that exists. And because, if you look at the training cost of these large language models, 30% of that cost is energy cost. My view is all the hyperscalers and all the startups will work towards reducing that cost because there's an instant ROI on that, basically, and it's possible. So I'm less worried about that problem, and it will be solved. But then from a practical approach standpoint, let's stop throwing large language models at every problem.
Yeah.
Right? There was still a race of between companies hey, my model is 1 billion parameters. That's how it started. Then 50 billion, 75 billion, 100 billion, or trillion parameters, right? You do not need those many parameters. For some of the problems we are talking about, even 100 million parameter model can do a much better job without actually overfitting on the lack of data that exists with 1/10 and 1/20th of the energy consumption. Again, so look at the problem first, and start with smaller models, see how they work. And if you start seeing the reduction, the plateau in their performance, then go to large language models.
It's also possible it serves as a stronger impetus for the energy transition. I mean, we're already seeing the big tech companies take the energy problem into their own hands and deploy nuclear in novel ways. And I think we're going to see a lot more of that. I think efficiencies in the energy transition can come out of this. I also think that the catalyzing more demand for fusion and faster transitions like that, as well as really what we're also seeing with the big tech companies is, I think, also a positive drive toward, in the interim, offsetting their emissions through subsidizing carbon removals, which, as we face a deepening climate crisis, removing carbon as well as methane from the atmosphere is absolutely an important piece alongside emissions reductions to remove the legacy emissions. And as the IPCC, my colleagues and climate scientists on that panel remind us that this is an important part of the solution. So the roles that big tech is playing in the removal space and subsidizing a whole host of different carbon removal companies, some of them represented in our portfolio at Propeller, as the oceans are the long-term sequestration for carbon on our planet. I think this is also a facet of it that shouldn't be overlooked.
One of the things that Read AI answered with on that question was efficiency. And I think it's important that efficiency first is always one of the best answers when you're looking at lighting or home energy use or vehicles. And there are two companies actually that came out of MIT that are really focused on this efficiency issue for compute. One of them actually, Liquid AI, just had an event, this past week up in Boston, releasing their product, which can train models at with a 1/20th or 1/10th the amount of energy. So you get this amazing ability of using less energy to train the models, and then even to run them, it's even less than that. There's another company, IR Labs, which is out of the Bay Area, but they started out of MIT actually in the class that I teach, and they have a way of making essentially bringing light and fiber to the chip and deeper into the computer process, so you can redesign data centers. And that's been 20 years in development. It's kind of ready to go now. So we've got these amazing efficiency opportunities, but it brings up an issue with efficiency. It's going to reduce the cost of training and building these models so low that everybody can now go build their own models. That companies, even individuals, will be able to train their own models at some point because it's going to get that cheap. And so this brings up a paradox, Jarman's paradox about as things get more efficient, the demand can go up. Now with a car, as the car gets more efficient, yeah, you might drive a little bit more, but even if it didn't cost anything for fuel, it's not like you're going to just drive all day, right? Maybe you do it for work and you're a Uber driver, but most people are not just going to drive more and more if their cars get more efficient. But in this case, with models, it's going to be, it's really going to increase the demand. And so I think one of the only things that's going to maybe address that is policy coming in and regulation. So, climate, energy, automotive, heavily regulated industries. How do we think about regulations in terms of AI and climate? And I know you have to leave, so maybe you can lead with that.
So I believe that public policy is critical for any country because you set up the strategy going forward. I'm particularly against mandates of any type because you dictate what consumers have to buy. Although we do need to reduce the CO2.
No.
So you find the way. Don't tell me the recipe for it. So I'm going to bring the point from Julie and you, Todd, on energy transition and efficiency. And let me give you an example of policy. So when you talk about the value of the vehicle, when you talk about EVs, the major pushback from consumers today is lack of infrastructure and the speed of the charging from the vehicle. It can take, anywhere from 15 to 25 minutes if it works. I think AI can help us reduce the amount of minerals that we use in the battery, reduce the amount of speed that you use to charge the car, and then the consumer will, and at a lower price, and then the consumer will come faster to EV. And now tying that to policy, how do you stimulate innovation, R&D, so that knowledge stays in the US and we develop that for the entire industry? I think you need to put all these things together, thinking on a macro way.
All right, and I think you have to leave.
And I have to leave.
To catch your flight.
I apologize. I have a flight to catch.
Thank you very much. Thank you.
Thank you. Bye-bye.
So any thoughts on regulation and AI, and potentially with a climate lens? So is there, maybe you say you have to even report if you're training a model, and if it's not using clean energy, you have to pay a tax, because it's not like you mentioned it was 30% of the cost.
Yeah.
It doesn't seem to be an issue for the folks that are paying for it in terms of what the energy costs are. They're willing to pay. That's not the problem. So if they have to pay a little bit more, is that the way to do it, or what do you think is the?
So I think as a former policymaker myself, as I said, I'm against any regulation so far. I think it will be a good problem to have that the cost of trading these models goes that low that even a developer in the remote part of China or Brazil or India can develop the next Facebook or can develop the next great entrepreneurial idea that can transform societies. I think it's a good problem to have, right? We are just speaking within the confines of the the MIT arena here, and we should recognize our privilege as well from that standpoint. And to me, it's a good problem to have when we can bring down the cost of training these models, and basically talking about giving equal access to every developer out there around the world.
That was the next question I wanted to get to, was accessibility for not just developing and training, but using and working with the models. But Julie, do you have thoughts on the regulation or the accessibility?
It's hard to anticipate what comes next and to be overly prescriptive about it when we haven't fully explored the edges of innovation here.
Are there other points that either of you want to add to the panel or add to the conversation?
I'll just add that going back to Julie's point about there's so much we haven't seen yet, and I genuinely believe that the next Zuckerberg will come from, as I said, because of the AI advances we are having, the next Zuckerberg will come from a remote part of India or China or Brazil, right? And we should enable that from an access standpoint. How many of you benefited from Coursera's deep learning courses? Yeah, Andrew Ng did an amazing work rolling out these courses for free for everyone. Now I would say let's have another version of Coursera in local languages that talks about like, hey, how do you look at applications and how do you think about deploying models and solving those applications in local languages with local context. And one other thing I would say is like I grew up in India where I didn't have access to a computer or internet until my college, right? I'm from a very small town in the north of India. The only source of education that used to be those cyber cafes, right? No. India used to have 500,000 cyber cafes at its peak where, people like me can go in and learn about the word. Now I think the time has come to think about the next version of cyber cafes and the next version of digital libraries around the world, right? Which are equipped with free compute credits for developers, which are equipped with like free courses, Coursera courses. And that when we'll start seeing, people who are more aware of the problems in their local world, like talking about context and large language models, those developers and inventors have the best context on how they can solve their local problems. And then they'll have the access to infrastructure, as well as compute, as well as some incentives from the government. And then we'll see like explosion of solutions to problems in not just in climate change, but education, poverty, and you name it.
So I'm smiling because the class that I teach is called Climate and Energy Ventures, and we've had over 60 companies that have come out of the class. Alums have gone on to start another 100 companies, and we are in the process of making this scalable outside of MIT. We expanded to UT Austin in Texas. We just expanded to Technical University in Munich. We're engaged with a number of other universities around the world. So I would love to potentially help make the learnings that we've had over the years accessible for everybody. How do we make this something that anybody can use? We're layering in several AI tools for the course. We did a RAG-based chatbot last year for the class. We've got tools that help with regulation and techno-economic analysis, and starting a whole business. There's a tool out of the Trust Center called Jetpack, which can help you go from idea to business plan. It used to be a semester-long course. There still are courses that teach that.
Yeah.
But now you can do it, at least a version of it, in about an hour. So this is the first time we're teaching the class where we're giving the students access to these tools. How do you see enabling people to use AI in a way that helps get to the right problem and maybe get faster to a solution versus it doing the work for them? Like, how do you envision humans engaging with AI? You mentioned they've got the on the ground experience and perspective. You can compare that with an AI that can have the very broad but also specific perspective. So it's like a way of sharing lessons learned. And this could be for an entrepreneur in India or anywhere in the world, or it could be for a scientist that's super deep in their expertise, but maybe they don't know that someone is working on another problem somewhere else. How do we use AI to help facilitate those connections that maybe help move progress faster?
I think this is such an important area to more rapidly expand the solution space in climate. This is an area you and I share a keen interest in, Todd, which is building on what Pablo said about the increasing climate extremes and how it's disrupting agriculture and supply chains. This is an area, Himanshu, you're deeply involved in developing tools to help anticipate these conditions, but also the nonlinear changes to the Earth system. And how do we potentially stave off some of the more catastrophic changes around Earth system tipping points and design interventions that can give us more agency on particular parts of the Earth system as we collaborate, learn, and work with the entire Earth system to amplify and boost the natural processes like carbon sequestration. And I think we have yet to see what that looks like to develop that sort of collaborative engagement with the entire Earth system from both a science, engineering, and innovation perspective. I think that is in our future.
I'm not sure we're about 30 seconds. You get the final word.
Yeah, I think Pablo talked about the example of self-driving cars, right? It's similar. I think of this in a similar framework, right? You can have you can train your models, autonomous driving models, but then you have to customize it as per the the local traffic conditions and city regulations. For every city in the US, it's different, right? I tend to see that similarly for in education as well, right? So you have a centralized model, like think about like what Android did as an open source around the world, or Linux did as open source operating systems around the world. But then the developers can come in with the tools available, and then developers can come in and create solutions for the local problems that they have. I call it like the autonomous AI cloud for the world.
That's a good thing to end on. I really enjoy that concept. So thank you very much to our panel.